Today we'll be demonstrating FreeMILL for VisualCAD, brought to you by Mexsoft Corporation. After downloading and installing VisualCAD, launch your VisualCAD application, either from your desktop or from the Windows Start menu. If a VisualCAD license has not yet been activated on your computer, the VisualCAD Get Started dialog is displayed when the add-in is first loaded into VisualCAD. You can go directly to running FreeMILL by selecting the Run FreeMILL button. You can also choose to evaluate the full product by selecting the Run CAM Demo button. All functionality is available except for saving and generating G-code. From this dialog, you can also access learning resources and activate your purchased product. For now, we'll choose the Run FreeMILL button. Docked on the left, you will see the FreeMILL wizard. It contains a series of tabs that will step you through the process from part setup to generating a toolpath and post-processing it to create a file that you can send to your CNC machine to cut the part. If the FreeMILL wizard is not displayed, first select the Home tab in VisualCAD, and then drop down the VisualCAD menu and select FreeMILL. The first thing we need is a part model or some geometry to machine. We could create geometry right here in the VisualCAD host CAD system. However, for this demonstration, we have a 3D part model that has already been defined in VisualCAD. Okay, let's begin. The first tab in the FreeMILL wizard is called Set Cutting Direction. This refers to the axis or orientation of the cutter while cutting the part. You can set the direction to align with one of the principal axes of the World Coordinate System, referred to as the WCS. By default, this is set to World Z. The WCS is a fixed, immovable coordinate system that exists in the 3D space of your part file. The WCS is also displayed on the graphic screen. However, the WCS is for reference only. It does not directly control the output of your toolpath. If I were to select World Y, you would clearly see another coordinate system that exists. This coordinate system does directly control the output of the toolpath and is referred to as the Machine Coordinate System, or MCS. Our goal in this step is not only to align the Z-axis of the Machine Coordinate System with the spindle of the machine, but also to orient the X and the Y axes parallel to the axes of the machine tool. This part will be mounted on the table of a vertical spindle 3-axis mill. This means that I want the Z-axis of the machine coordinate system straight up towards the spindle of the machine. Then I want the X-axis towards the right and the Y-axis towards the back, which happens to be the same as the World Z. So, when World Z is selected, the machine coordinate system is coincident with the World Coordinate System. This is the default setting. This is then the correct cutting direction for the machine coordinate system for my part in this setup. Now we move on to the next tab in the FreeMILL wizard, called the Create Part Stock tab. We use this tab to define the stock material or the workpiece that the part will be made from. FreeMILL looks at the part geometry and creates a minimum box that it uses as the stock material. The dimensions are shown in the Part Bounds section here. In the fields below, you can change the stock dimensions by defining offsets. We'll add a part offset of 0.25 in both the X and the Y directions. With the stock defined, we can now move on to the next tab in the wizard, called Set Work 0. This tab is used to define the program origin, referred to as the Work 0. There are 3 options to choose from. For this part, we will choose the Set to Stock Box option. On the CNC machine, I will be positioning the stock against 2 locating pins on the back side and 1 stop pin against the left side. Therefore, the natural place for me to put the Work 0 is at the back left corner. So for 0 position, I will select Northwest. I also want the work 0 located at the top of the stock. So for 0 face, I will select highest Z. As you can see in the graphic screen, this moves the machine coordinate system to the desired location. Now, all coordinate values in our toolpath will be relative to this work 0 origin, according to the axes of the machine tool coordinate system shown here. So far, we've set the cutting direction, the stock, and the work 0. We will use the next tab in the FreeMILL wizard to create our cutting tool. FreeMILL supports 3 tool types: a straight ball mill, a flat end mill, or a corner radius mill, sometimes called a bull mill. I'll be using a 1/2 inch diameter ball mill, and the default dimensions shown for the cutter and the holder are acceptable. With the tool defined, the next tab is used to define the cutting feeds and speeds. You can set the spindle speed in RPMs, as well as the cut, engage, and retract feed rate values. You can refer to the diagram in the dialog as a reference. Now we're ready to cut our toolpath. With the Create Machining Operation tab selected, we see that FreeMILL supports the most commonly used toolpath, called parallel finishing. Parallel finishing cuts across the face of the part, each pass being separated from the next by a step-over distance, and each Z level separated by a step-down distance. We'll set the step-over to 0.125, the step-down to 0.25, and for the cut direction, we'll select a long X. Now we'll pick Generate to see our toolpath displayed in the graphic screen, and there it is. You can also perform a quick simulation to see your process stock model. We'll pick the Simulate button, and there it is. You can also toggle the display of the toolpath in the graphic screen. Now that we've generated and simulated our toolpath, we can move to the last tab in the FreeMILL wizard and post-process our operation. Post-processing converts the toolpath you see on the screen into a post file containing G-codes that the controller on your CNC machine will use to cut the part. You will find that FreeMILL currently supports over 300 different post-processors. I have chosen the Haas machine, so now we're ready to execute the post. The Save As dialog displays, allowing you to specify a file name and location for your post file. Once created, the post file is displayed in Notepad, listing the G-codes and M-codes for the Haas machine controller. If you look down through the post file, you can see that the Z-axis values are all negative. That's to be expected because we placed the work 0 origin at the top of our stock material, so that all cutting will be in the negative Z direction. This completes our demonstration on FreeMILL, the cost-free milling plugin included in VisualCAD from Mexoft. If you need more milling capabilities than FreeMILL provides, have a look at our full-featured Visual Mill module, which now includes our Nest and Art modules.